4.5 is on rates of mortality, fertility, and morbidity. The rate describes the frequency of occurrence of some event. It is the relative frequency of an event multiplied by some number, typically a value such as 1,000 or 100,000. A rate could be expressed in the form of A divided by B times K. And our textbook will assume a 1-year time interval as well. A is a frequency count of the number of people for whom the event occurred. B is the total number of people exposed to the risk of the event occurring. And K is the multiplier number, which is that 1,000 or 100,000, for example. And in terms of these rates, we refer to as infants as babies who are born alive, neonates as infants under the age of 28 days, fetal death as a fetus that is delivered without life after 20 weeks of gestation, and neonatal death as an infant dies under 28 days of age. Now, when it comes to these mortality rates, we have several types. The crude or unadjusted mortality rate takes the deaths divided by the population size times that constant K. The infant mortality rate, the deaths of infants under 1 year of age, divided by the number of live births times that constant K. The neonatal mortality rate, deaths of infants under 28 days of age, divided by the number of live births times that constant K. The fetal mortality rate is the number of fetuses delivered without life after 20 weeks of gestation, divided by the number of live births plus the fetuses delivered without life after 20 weeks of gestation, times the constant K. And then perinatal mortality rate is the number of deaths plus neonatal deaths divided by live births plus fetal deaths times the constant K. For fertility rates, we have two types here. The crude birth rate is the number of live births divided by the population size times the constant K. And the general fertility rate are the number of live births divided by the number of women aged 15 through 44 times the constant K. For morbidity or disease rates, we have the incidence rate, which is the number of reported new cases of the disease divided by the population size times the constant K. And the prevalence rate is the number of people with the disease at a given time divided by the population size at the given point in time times the constant K. So with all those formulas in mind, we have an example here. For a recent year in the United States, there were 2,515,458 deaths in a population of 312,799,495 people. Use these values with a multiplier of 1,000 to find the crude mortality rate. So for this crude mortality rate, there'll be A divided by B times K. A will be the number of deaths, so 2,515,458. B is the population of people, so 312,799,495. And K is 1,000, which is that multiplier. So 2,515,458 divided by 312,799,495 times 1,000. This calculation, when you toss it into a calculator, gives about an answer of 8.0. So the death rate is about 8 people for each 1,000 people in the population for this particular year. In the United States, I should probably add. In the United States. Another example, The infant mortality rate is a very important measure of the health of a region. According to the United Nations, the worldwide infant mortality rate is 49.4 per 1,000 live births. For a recent year, there were 3,953,590 live births in the United States, and there were 23,910 deaths in infants under 1 year of age. Using a multiplying factor of k is equal to 1,000, find the infant mortality rate in the United States and compare it to the rate of 2.1 for Japan. So the infant mortality rate, this would be a divided by b times k. A is the number of deaths, so 23,910. B is the number of live births, so 3,953,590. And k is 1,000. So 23,910 divided by 3,953,590 times 1,000. This gives us an answer of about 6.0. So the infant mortality rate is about 6 per 1,000 infants under 1 year of age. It is substantially higher or more or greater than Japan's infant mortality rate of 2.1 per 1,000 infants. A couple of other definitions are the crude rate, which is a single value based on the crude totals, specific rates, rates specific for some particular group or for some particular cause of death, and adjusted rates. These rates make adjustments for important factors such as and may include complicated calculations. I shouldn't say may, usually have complicated calculations. Thank you.